Welcome everyone to this evening's webinar on Eco-Retrofit for Householders, Unit 4 Ventilation. I'm delighted to have Marianne Heaslip of URBED to speak to us on this subject this evening. So I'm just going to do the introduction and the welcome, and then I will hand over to Marianne to do the main presentation this evening. Then after Marianne's presentation, it'll take over to Kieran, who is going to run the question and answer session, putting the questions to Marianne. So please put your questions in the Q&A, and Kieran will put them to Marianne at the end of the presentation. And then towards the very end, there'll be another poll, a couple of information about other events, and Kieran will close at 7:30. So for those of you who haven't already come across Cumbria Action for Sustainability, we do a lot of projects, a lot more than just talking about retrofit or green homes. And rather than repeat that on this presentation, because I've said the same thing in a number of other presentations, I'd encourage you to go to the website and have a look around and see what we're doing. But a lot of what we're doing is really geared towards our vision of a zero carbon Cumbria and trying to achieve that. Within the energy services team where I work, we have various free services and schemes listed on the left, and paid for schemes listed on the right of this slide. So whether you're eligible for our Call to Cozy Homes service, or whether you just want a free advice call or a retrofit consultation by phone, that's something that you can have by giving us a call. And on the other side, if you want a whole house energy audit, or perhaps some thermal imaging and other energy advice, we offer those paid for services too. And of course, we run courses and webinars, some of which are free, some of which are paid for. And thanks to the energy redress funding that we have, this webinar is free, but we're really grateful to those of you who give donations when you book on or through the CAfS website. And that means that we can do more with what we have. So Marianne, Marianne's a Technical Director at People Powered Retrofit and an Associate Principal at URBED. And Marianne's been working on retrofit projects and involved in the development of the whole home retrofit planner tool that we use at CAfS, and that is also used in Manchester by Marianne and the team to assess the energy demand and so on of the houses that we analyse. And Marianne has worked on individual homes, but also on housing associations and community organisation homes, where you're dealing with a lot of homes all together, so working at scale, and on lots of research or research related projects. So she's got really good insight into this subject. So without further ado, I'm going to hand over to Marianne. I'm going to say goodbye and disappear, and I'll leave you with Marianne and Kieran for the rest of the evening.
Okay, that's brilliant. Thank you, Tina. And I will just share my screen now. So thank you everyone for coming along. I hope this is useful and interesting. It's a bit of a start from first principles thing with ventilation as well. So we're not going to dive right into talking about different types of ventilation kit. We're actually going to do a little bit on why you need ventilation in the first place, and some of the things that you need to think about with it. So that's essentially the agenda for tonight. There's a quick recap at the start on the whole house approach, which is talked about a lot more in the introduction session that some of you might have already been on. There was a session on Monday, and there had been a previous session last month as well. So it's a very brief recap just to set the context. And then we're talking about basically why you do ventilation, some of the standards that you need to be aware of, and some of the different options, and also very simple improvements you can make right now. As I think Tina introduced me well enough, I don't need to say much more, but yeah, this is the organisation that I work with in Manchester. Comes out of a collaboration between Carbon Corp, which some of you might have heard of before, and URBED, which is a design and research worker cooperative in Manchester that I also work for. So very briefly then, we really encourage people to, when you're thinking about retrofit, to consider the house as a set of integrated systems that all have an effect on each other. So you've got the fabrics, so the walls, floors, roofs, windows, doors. You always get heat loss or sometimes heat gain through those. Then you also have your ventilation system, hopefully. Not all houses start out with an actual system, sometimes it's just window opening. Usually in our climate, you need to add a heating system into that, and so that will be interacting with your ventilation and with your levels of fabric heat loss, depending on how well insulated things are and how many drafts and how leaky your house is. Then you've got lighting and appliances as well. And the thing that we should never forget is that there's also people, because people have a physical impact on these systems, especially when it comes to thinking about ventilation and indoor air quality, because we're generating moisture, we're generating pollutants, which is why you need to think about ventilation. And we also need to think about, because people will be using these systems, and whether or not they can control them, whether or not they feel comfortable and happy that they're able to control them, is all incredibly important to making sure that we've got comfortable and healthy homes. There's a couple of resources that we point you to that are quite helpful in thinking about houses as complex systems. One of them is the Responsible Retrofit Wheel that was developed by the Sustainable Traditional Buildings Alliance. That is incredibly useful at showing you what some of the interactions between different things you might do within your home as part of a retrofit are, where there might be risks, where there might be things that you would want to avoid, and where things might actually work well together. And the hope and the aim with any retrofit is really that the changes that you're making, the upgrades, the improvements that you're making are well designed, they're well installed, they're understood by the person in the house, and they work together well, and you don't have issues with maintenance or unintended consequences. So that's what we're aiming for. I'll just skip over this, but just to illustrate that we're not, one of the reasons why we have to take a whole house approach and be very aware of context as well is that houses are all very different. Even between Manchester and Cumbria, the housing stock is quite different. Superficially, in some cases, there are similarities, but things like the brick and the slate used, and you get a lot more stone-built buildings in Cumbria than you do in Manchester generally. And the age of the properties varies, and what was built at different times in different bits of the country varies. So understanding all of this is really important. Because we've changed a lot about how we build over the years, originally we were building places that were almost quite open to the external environment in terms of moisture and also in terms of air, so they'd kind of absorb and release moisture. You'd have fires that were drawing through a lot of air, ensuring that the house was very well ventilated in that respect, and you'd get your heat from your radiant heat sitting close to the fire to keep warm. Whereas the latter half of the 20th century onwards, we've tended to build buildings that are a lot more closed. So we've not always, but generally trying to keep drafts out rather than absorbing and releasing moisture, just trying to have impermeable barriers to it. And I suppose one of the things that makes retrofit interesting is that most of our older housing stock, so the stuff that was built in the 18th, 19th, early 20th century, it might have started out like the image on the right there, but actually over time it's had things added to it that make it a bit more like the image on the left. And especially when you come to thinking about indoor air quality, moisture, ventilation, you need to consider that. So that's just a bit of an intro. The reason that we're really concerned about ventilation in buildings mostly is because we want to ensure a good internal environment. And that's something that's healthy and something that's comfortable. This is because we spend, probably especially over the last couple of years, we spend a huge amount of our time indoors. So the air that you're breathing, the environment that you're within, it has quite a big impact on your health, and indoor pollution of various kinds can be quite a serious health risk. If you've got a house that's got problems with mold, there's a risk that it's going to have an impact on your health. And usually issues with mold are to do with things around indoor air quality. That's just one example. So looking at what causes indoor air pollution, there are lots of things that it affects. So things that you can say, actually, this place might not be such a great atmosphere because you're having problems with allergies, you're having issues with headaches, with breathing. If you get a bunged up nose a lot of the time, that can be to do with the levels of poor indoor air quality. Or if you've got irritation, and even there are some studies that suggest that things like memory loss or dizziness and fatigue and depression can be affected by indoor air quality. I think often gets talked about a bit less now because I think we've maybe got better at designing office buildings, but there was a lot of talk of sick building syndrome in the kind of 80s, 90s. A lot of that was to do with some of these issues. One of the really big ones, and that it's completely unavoidable because humans are 70% water, is water vapor. And it's one of the things that can have the biggest impact on the quality of the air inside your home. We just generate it every day in what we do. So we have, even just breathing out, you're breathing out water vapor, but things like washing and cooking are kind of really key ones that can create a lot of water vapor that goes into the air in your home, that if it hangs around too much or there's too much of it, can cause you problems. You can change your behaviour to a degree. So things like rather than drying your laundry over radiators inside, if you've got an external line or if you've got a kind of planned airing cupboard with a bit of ventilation in it, that can really help. But there are really limits to what you can do because humans generate moisture. And then there's also the environment around your home. So it's not just the moisture that you're generating, it's also the moisture that's coming from the external environment. And in somewhere like, well, anywhere in the northwest of England, really, the relative humidity is high for much of the year. I grew up and work in the just general all-pervasive moisture is kind of hard to get away from. It can be particular to where your house is in the relation to water courses or the water table as well. So that can, if that gets into the structure of your house, that can also increase the amount of water vapor and moisture in your home, which just makes it a little bit harder to manage. And because of all of that, you need ventilation, because really ventilation is the main way that you're able to get rid of that excess water vapor. There's a really useful video from the UK Centre for Moisture in Buildings with the link there. I think you're going to get these slides after the session, so you'd be welcome to go and have a look at that. It's just a really nice illustration of some of these issues. So when we're talking about humidity, it's important to understand kind of what level of humidity you should be aiming for. This piece of research was done to inform ASHRAE, which is kind of a building services professional organisation in the United States of America. it's quite old research, but I've never come across anything that's been as succinct and bettered it as yet. But essentially the suggestion is that being somewhere in the mid-range for relative humidity is the ideal, because if your area is too dry, then as you can see on the little chart there, you can get problems with bacteria and viruses, and it starts to affect things that might have a negative impact on people's ability to breathe. If your relative humidity is too high as opposed to too low, that's when you start to get issues with condensation and mold, and often various different forms of fungi. And also chemical interactions, so things like volatile organic compounds can be released much more quickly at higher levels of relative humidity. And so I think it's also important to understand what relative humidity is, and it is a relative measure of how saturated the air is. So it's to do with how much moisture the air is holding and is at that temperature able to hold. If the air is 100% saturated, it means it's reached the dew point, which some of you, it might be a term that you've heard. Any more moisture or water added to the air beyond that point will stop being a vapor and become a liquid. So that's what happens when you have fog. That's basically moisture droplets suspended in the air, or condensation on a window pane. So if warm, wet air hits a cold window pane, it loses its ability to hold on to that moisture, so it condenses out in liquid form. There's a little tool here, a Dewpoint Calculator, which again, the link is there and you're able to go and have a play around with it. It's quite useful for understanding some of these relationships, because it is a kind of dynamic inverse relationship between temperature and relative humidity. That can be quite good for getting a feel of what's going on. This inverse relationship happens basically because warm air can hold a lot more water vapor than cold air. The holding capacity of the air kind of increases as the temperature increases. So you can have the same amount of water vapor in a volume of air, but at 10 degrees centigrade, it's saturated, and at higher temperatures, it's got a much lower relative humidity. If you want to have a play around with this, there's some links there as well, but this has important implications for buildings, and especially when you start to think about ventilation at different times of the year. As I say, yeah, the opposite is true if the air cools. If air cools down, it holds less water. As I gave the example before of warm, wet air hitting a cold surface like a window, as I think the video there sometimes happens at parties. And this is where you get condensation on windows after a shower or while you're cooking. Especially if they're single glazed windows, you'll notice the difference, because a single glazed window, the surface temperature there is liable to be cooler than if it was a double or a triple glazed window. So yeah, essentially, if the total amount of water in the air stays the same, which is what we refer to as absolute humidity, so you measure that in grams per meter cubed usually, or micrograms per meter cubed. But then the temperature goes up, the relative humidity will go down, and vice versa. In your house, what this means really is that if your house is relatively cold, it's likely that the relative humidity in your home will be higher. So if you're keeping your house at more like 15 degrees rather than 18 or 20 degrees, in the same street next to your neighbour, that will probably mean that the relative humidity in your home is higher than that of your neighbours who might keep their house at closer to 20 degrees. If you're having problems with moisture, although it's not I appreciate, especially with gas prices and energy prices going up, one of the best ways to deal with problems of high levels of humidity in the home is actually to heat your home slightly more. It's one of the reasons why, if you've just replastered your house and there's a lot of moisture in the plaster, it's one of the reasons why people recommend that you keep radiators on low in that room and open all the windows, because you're venting out the moisture and you're also reducing the relative humidity by keeping the room a little bit warmer. So throughout the year, relative humidity is going to change as well. It's not something that's a constant. It changes with the climate. So in summer, generally, the external relative humidity is lower, even though the amount of moisture, the amount of water in the air might actually be higher. It's because the air is warmer, therefore the air's not getting as close to its saturation point. The reverse happens in winter. So relative humidity might hover around 100%, so the air might be permanently close to reaching dew point. But because it's colder, it's carrying less moisture overall. And what this means in your home is that if you bring in that cold air and heat it up from, say, 5 degrees or even 0 to 20 degrees Celsius, the total amount of water vapor in the air isn't necessarily going to change. And in fact, because of activities in your home, you're probably going to add to it slightly. But the overall relative humidity will probably drop. And that's why if you're going to get problems with dry air, it tends to happen more in the winter than at any other time of year, because if you're bringing in that cold air. This is a kind of a good thing, because what it means is that better ventilation in winter with a little bit of heating should keep your humidity down. And if you're getting dry air, that's probably a sign that you're over ventilating to a degree. It does depend a little bit on how densely occupied your home is. So if you've got one person living in a relatively large house with large volumes of air, you're less likely to, well, you're going to be generating less moisture than if it's lots of people living in a smaller home. If you've got high levels of humidity in the winter, that's when you start to have real issues with like condensation and mold. Because whilst the humidity might be, whilst the humidity is high, there's more chance of it hitting those cold external surfaces. So this is when you'll probably start to notice things like you get spots of mold around window reveals and that kind of thing. And that's just that warm wet air hitting the cold surfaces in winter. And that's definitely something that you can start to deal with through ventilation. In spring, summer and autumn, if you're monitoring your internal conditions and you're looking at your relative humidity, especially in somewhere like Cumbria, because the internal and external temperatures are a lot closer together, bringing in external air to try and get rid of moisture and to reduce the relative humidity in your home is going to have a lesser effect, because the external air that you're bringing in has already got more moisture in it, and you're not going to have that benefit of taking cold air, warming it up and reducing the relative humidity that way. But I would also say that it's higher levels of humidity in the home are kind of, well, they're to some degree unavoidable, but also they're tend to be less of an issue in the middle of summer or even in spring and autumn. I don't know how many of you might have felt, well, when you feel like a room is a bit stuffy, that can be a sign that the relative humidity is quite high and the humidity is quite high, but it's much harder generally for us as humans to sense this. We're much, much better at sensing heat. But if there are, yeah, if you sense stuffiness, or if you feel like if you develop a bit of a dry cough, which I know other reasons for having coughs at the moment as well, but if you develop a bit of a dry cough, that can be a sign that the atmosphere is a bit dry as well. But because we're not very good really at understanding whether the air in a room or the environment within a house is humid or not, it's really useful to look at monitoring kit for this so that you can understand it better. And it's possible to get the little image there of the hygrometer is something that you can get for, you know, £10 or so from a hardware shop, and it's just nice to keep an idea of things. You can get more advanced continuous monitoring as well if you are interested in keeping more of a track of it. The graph there is from a retrofit that was done in Manchester that I was involved in, and the householder there's Dom, who does a lot of graphs. I would highly recommend any of you are on Twitter. Dom's definitely worth a follow because he publishes lots of graphs if that's the kind of thing you're interested in. And he just kept a track and showed that basically the ventilation system that was installed as part of his retrofit really helped to keep his house a bit drier and a bit more comfortable in the middle of winter, especially. We often get asked, especially when considering traditional buildings or older buildings, people say, well, you don't necessarily, do you really need a ventilation system? Do you need to manage moisture through ventilation? Because isn't it possible for things like limes and clay plasters and that kind of thing to deal with moisture? And that's through a process known as hygroscopic buffering. So that's limes, clays, kind of absorbing moisture when the humidity is high and releasing it again when the humidity reduces. It achieves a kind of stasis. What I would say is that does have some effect, and it can be a beneficial effect, but it doesn't negate the need for proper ventilation, because there are several other reasons to ventilate that. It's not just about moisture. One of the really big ones, which is a risk that needs to be considered quite seriously, is pollution from fuel burning. So if any of you have got wood burning stoves or open fires or gas fires, then you do get a degree, a kind of unavoidable degree of indoor pollution from those. The big risk to try and avoid completely is carbon monoxide. So you try and do that by making sure that things are burning properly, and definitely by having a carbon monoxide monitor. But as well as that, you get small particulates, and you can get nitrogen dioxide, which is not great for asthmatics. So you even get that from gas hobs and things. So it's best if you're going to have fuel burning appliances in your home, which I think in a lot of cases people are realizing that we probably need to move away from, then you need to make sure that you've got adequate ventilation so that you're not being poisoned by these things. The other one, which does apply in some of Cumbria at least, is radon gas, which is a carcinogen. Where it occurs depends on the rock formations and how they're laid out beneath your home. But you, especially if you're doing work on your home as part of a retrofit to make it more airtight, there's a risk that you end up trapping more radon within your home, and that's not very good for your health. So you need to make sure that that is considered, and your ventilation system, making sure that your home is well ventilated is part of that. Although there are other things like radon barriers, which are a lot harder to do in retrofit, or sumps that vent the radon away that might need to be brought in as well. And then the other one is carbon dioxide, which, although not poisonous, at least not at the levels that you're likely to encounter even in a not very well ventilated home, at higher levels it can lead to kind of drowsiness, and it's just generally not great and not pleasant to be in a room with too high a level of carbon dioxide. So ideally you want to keep concentrations of that below 1,000 parts per million. Different ventilation systems have different levels of success overall at achieving that. Carbon dioxide is kind of useful in retrofit because it's one of the ways, it's a bit of a proxy that can be measured for all the other potential risks of indoor air quality. If you want to know more about that graph, I think there's a study I can probably dig out for you, but there's some writing by Kate DeSelencourt as well that's worth a look. And then, yeah, just beyond those ones, which are the kind of some of the key ones to think about and risks to health, really, I guess. There's lots of other potential sources of indoor pollution that you need to control or get rid of, some of which are just unpleasant, but they might be a sign of something else, so just smells and odours. And then there's off-gassing and VOCs from floor coverings and furniture and cleaning chemicals, that kind of thing. It's best not to have lots of these in your home. If you can, controlling those at source is a good idea. So using low VOC paints, but there are limits sometimes to what that can do, and even natural materials give off a degree of volatile organic compounds. So you do still need your ventilation to deal with those as well, the ones that you can't prevent coming into your home. Yeah, and pet smells and all the rest of it. So, sorry, I've probably just kind of big information download there. So have a bit of a knowledge check. Would you be able to, the way that we do this is we ask you to write your answer in the chat, but not press send for a few seconds. So if you are all able to maybe type out in the chat what you understand the difference between relative and absolute humidity to be. And then when I say, I'll ask you to send it in about 15, 20 seconds or so. This is partly just to make sure that you're all still there and I haven't frightened you all away. Yeah, so if you have managed to answer that question and you want to hit send now, then please do. Yeah, I can see Mark's comment as well. I'm afraid this session is meant to be an introduction to ventilation, so we're going to talk about the basics of ventilation next. It's just really important to understand why you might ventilate in the first place. But yes, absolute being the actual amount of vapor in the air, relative being the one that's affected by temperature and is a measure of how saturated the air is. Brilliant. Thank you very much. So just some, before we get into different types of systems, just some basics, and thank you all for engaging with that. Just some basics around ventilation systems and some of the definitions and terms. When we're talking about ventilation, what we're generally defining it as is a planned exchange of air with the external environment and living spaces. So this is to provide fresh air and to remove pollutants, and sometimes also to moderate temperatures. So, you know, opening the ventilating in summer to keep your home a bit cooler. There's two basic types of ventilation. That's purge ventilation. So that's when maybe you've burnt some toast and you throw all the windows wide open to get a rapid exchange of air. And then you've got background or trickle ventilation, which is a kind of continuous low level that's just topping up to make sure that the air quality is being maintained. There's kind of two basic methods that are referred to, either natural or mechanical, or sometimes natural is referred to as passive. I'm not a big fan of using the term natural in this. I think there's kind of, yeah, there's value judgments in there that are could be quite interesting, but that's probably another chat. But the thing is that there's lots of different ways of achieving ventilation. There's lots of variation where there's mixed mode ventilation as well. So you might do some passive and some mechanical, depending on the time of year in the house. And if you've got opening windows that you use occasionally to ventilate space, then you've got a form of mixed mode ventilation, as they would call it. It's really important not to confuse ventilation with infiltration, which normally, if you're not a building physics person, you would just call drafts. So infiltration being unplanned air movement through cracks and gaps in the building fabric. The image there is of somebody's lovely new insulated loft hatch that they didn't fit very well, so it's actually got drafts all around the edges. You really want to avoid drafts. I know that sometimes people talk about it as one of the ways of ventilating a home. It's not the best way of doing it. You want really to have planned routes for ventilation. It's because it's unreliable. So I've lived in very drafty homes that also have bad air quality when I've lived in various kind of terraced houses around the place. So it's no guarantee of air quality. It also takes you warm, wet air from your living spaces, your kitchens, your bathrooms, and potentially lets it into parts of the building fabric where you really don't want it to go, where it can condense and cause problems with rot and mold. So yeah, best avoided, not to be confused with ventilation. There is also construction ventilation. So this is where you might need to ventilate a subfloor. If you've got suspended timber floor and you're ventilating underneath the floor to maintain, again, it's to try and prevent moisture problems generally, or in roofs or sometimes walls with rain screens. But at the moment, that's not the type of ventilation we're talking about here today. It's still a type of ventilation, but we're concentrating on living spaces. We're doing that because, well, ventilation, even of living spaces, can protect the building fabric, because if you're not ventilating the living spaces well, you've got buildups of moisture, you can end up with the issues like in the image there, which was actually exacerbated, I think, by a leaking gutter on the outside face of the wall as well. But you start to damage the building fabric and damage wall and floor surface, wall and roof surfaces. You really want to avoid that. So removing some of that moisture so it can't cause the problems is a good idea through ventilation. It's very useful to also avoiding overheating. So if you want to avoid overheating, and depending on what happens with the climate in the future, but there's a good chance that things might become a bit warmer, even in Keswick. So making sure that you're ventilating in the summer to try and avoid overheating is a good idea. That has to be kind of combined with sensible approaches to shading and glazing, but ventilation is a big help there. And I know it can feel a bit counterintuitive, I guess, because in retrofit, we're often talking about making a house more draft-proof, airtight, but you're changing, yeah, and then you're talking about making it more airtight, but then putting some holes in it to create ventilation, which can seem a bit strange, but actually what you're doing in that is you're changing the air movement patterns, and you need to make sure that your ventilation is then in a very planned way, making sure that you still get that you do get good indoor air quality. There's a really kind of common quote from Colin King at the BRE saying any retrofit project that doesn't consider ventilation is a condensation project, and I've definitely seen evidence of that in the past. Yeah, as I say, it needs to be part of any retrofit project. And the other thing people say is seal, tight and ventilate, right? So you're sealing all the gaps and the cracks in the building, reducing heat loss, and then you're ventilating to ensure good air quality. Right. Standards and regulations. I won't spend too long on this because there's some stuff that you should be able to look at in more detail if you're interested in, but in general, probably worth being aware of the building regulations in relation to this, at least asking if you're getting a ventilation system designed, if you know how it is compliant with the building regulations. And then there are some further standards that you can ask for and maybe set as part of your specification to say, right, this is, I don't want to just meet the building regulations, I want to go beyond that and meet another quality standard. With the building regulations, the key requirement is to not make matters worse, but in any kind of decent level of retrofit, you're going to be making potentially quite big changes. So you need to have a look and make sure that you're in providing adequate fresh air, making sure that dangerous pollutants from fuel burning is removed, and protecting the structure from moisture. So that's kind of the reasons behind the different parts of the building regulations. If you look on the planning portal, all of the building regulations approved documents at least are there. So that's the guidance documents, and they're arranged in alphabetical order, but these are the key ones for ventilation really. There is a new Part F about to come into force in summer, and happily it's been updated a little bit because there was a recognition it wasn't quite working before, and the link between that and Part L, which is the one that covers energy efficiency, essentially wasn't quite there. It now provides a bit of guidance about what depth of retrofit, at what point in a depth of retrofit you need to start to think about ventilation upgrades and when it's likely to be needed. So that's quite useful. There's a little table in there. If you're wanting to go beyond building regulations, so legally you should be compliant with the building regulations, but that's a kind of minimum standard. It's not necessarily best practice or even what you should do in your given circumstance. You can look at the other end of the scale almost to a standard like Passive House, which I won't read all of that out, but it sets some quite high standards around efficiency of ventilation and comfort and noise, which is often a big problem with ventilation systems, that they're too noisy so people switch them off, which obviously doesn't help anyone. Slightly more relaxed than Passive House, but using some of the same methodology, is the Association of Environmentally Conscious Building. They have a building standard and they also have a retrofit standard. The tables on the slide here cover those. And they set out kind of, again, they talk about noise, they talk about efficiency, they talk about comfort. If anyone really, really wants to get into the nitty-gritty of all of this and understand it to the level that a professional would understand it in this field, then I would recommend looking at the ACB Cabin Light Retrofit Training, which is like an online training course that goes into a lot more depth on all of this. And just a note to say that on fuel burning appliances, you really need to look at Part J of the building regulations, but possibly also refer to heat and gas safe, because as highlighted earlier, there are some quite major health and safety risks around this if you don't get it right. I will just skip over this for now because there's a relationship between air tightness and ventilation, but what I would always argue is even in a quite leaky house, you'd still need to think about having a planned ventilation system, because hopefully the house won't be leaky forever, and just because it's leaky isn't a guarantee. Though it does help to have a more airtight, draft-free house, it helps with the efficiency, especially of heat recovery ventilation systems, because more of the air that otherwise might be leaking out through cracks and gaps is going to go through that ventilation system. Right. Last section, really, of all this, talking about particular ventilation systems. So hopefully all of that has given you a grounding on why it's needed. Some of the other things that you might need to ask people for, and the regulations or the standards that you might ask about. Ventilation systems themselves. I would say there's lots and lots of systems to choose from. Lots of room for confusion in this. You've got your basic mechanical versus passive. So that's something with a fan in it that's forcing air around versus something that's reliant on the buoyancy of air or the chimney effect, or on just the wind blowing past the house and sucking air out the house, that kind of effect. Then you've got your whole house versus single room. So that's either a ventilation system that covers the entire building, or sometimes ventilation systems just are kind of installed in a single room to deal with the issues in that room. And then you've got extract only versus supply and extract. So some systems are designed so that the fan unit is just pulling air out of the house. Some systems are designed so that you've got air being pulled out of the house, but you're also supplying air into the house, into different rooms. Just to go through each of those systems in turn. We've got natural here, but it's not really a system. Basically, this is just, and I've come across it fairly often in houses where there's effectively no ventilation system other than opening windows. And your purge vent in this condition is just to open your windows a bit wider. It's really simple, but it's incredibly dependent on context, on the weather, on the climate. You might forget to open windows. There's conflicts with security. So if you're reliant on opening windows for fresh air, but you live in a ground floor flat and you're worried about someone breaking in, that's a problem. If you're near a busy road, that's a problem as well. So even bringing air in creates noise and potentially pollution problems as well. So not to be recommended. The next one, which in the building regulations is described as System 1, this is essentially intermittent extract. So you've got trickle vents in your walls and windows, so they're just kind of basically small slots, small holes in walls or windows that allow air in. And then you've got extract units in wet rooms, so kitchens and bathrooms, that can be activated by a switch or humidity control, and they just come on as and when you need them. So it's when you put your cooking and you put your cooker hood on, and that extracts the kind of fumes and the moisture from your cooking. But then once you're done cooking, you switch it off again. It's pretty simple, pretty cheap to install and run. The evidence from various retrofit programs is that it's really not sufficient to ensure good air quality, especially in more airtight homes, but even in very leaky homes, it's not going to do the job. It can also be quite noisy because the fans are only coming on intermittently, so they're only coming on when you need them, when you've had a shower or whatever. They have to kind of pull through quite a lot of air quite quickly. So they have to move quite fast. So it can be noisy. It can be especially annoying if you've got, although this is true of the boost or the purge ventilation in a lot of systems, if someone goes to the loo in the middle of the night and your fan comes on and it's really loud, or if the fan's like near a room where you don't want to be disturbed, what it can sometimes lead to, sadly, is people just flick the isolator switch and leave them off because they're too noisy and annoying. They are a bit unreliable as well in a lot of respects, because they rely on humans to remember to switch them on sometimes, and we're all fallible. So Building Regs System 2 is passive stack ventilation. The way that this works is you've still got your trickle vents in some of your windows, usually in your living rooms and bedrooms, but then from your wet rooms, so from your kitchens and your bathrooms, you've got a duct that goes all the way up to the roof, and it extracts air, relying basically on the buoyancy of warm air. The purge vent with this is really just window opening, or sometimes they will add a kind of small fan unit to one of the ducts if you want to get a bit of a boost. I think in some ways this is really good in that it doesn't have many moving parts and it doesn't need much maintenance. And some of the systems have a degree of demand control or humidity control because the vents open wider or close up a bit depending on the humidity in the room, or sometimes pressure. And it's really quiet. But it's very, very dependent on context and weather and climate. So on very still, warm days, it's kind of reliant on a temperature difference between inside and outside that in turn creates a bit of a pressure difference. So on a still, warm day, it's not going to work very well because there isn't going to be a kind of stack effect, a buoyancy effect driving it in the same way. Some systems rely more on air, kind of on wind blowing over the ridge vents. So again, that will reduce its effectiveness, either if it's not very windy, or if your house is in a very sheltered position, it's not going to kind of work as effectively. It can be a bit tricky to retrofit as well, because of the ductwork that has to go kind of all the way from the ground floor up to the roof ridge. So yeah, and what I've done a few post-occupancy studies on systems like this in retrofit, and it can work quite well in the right conditions and in houses that aren't too, there aren't lots of people living in them and lots of moisture being generated, but it can not work at all if the conditions aren't right. It's not reliable in that way, I guess you'd say. And it's not necessarily very cheap either. For some systems that can get quite complex, you're talking hundreds, if not thousands of pounds potentially. A system that I will mention that I think in the new part F it might actually get a glancing mention, but until recently it wasn't mentioned in the building regulations at all, is positive input ventilation. This is something that a lot of housing associations have put in because it was sold as being good for getting rid of condensation problems. The way that it works is instead of extracting air out from your house, it pushes air into your house. The picture on the bottom right there is kind of one of the units in the loft space. The theory was by drawing air from the loft space, it means that it's already warmed up slightly. So you're not bringing in cold air from outside, but you're pushing in air that's kind of from a sheltered but unheated space. I have a few questions about that, because if your loft is very well insulated, then there shouldn't be that much warmth in your loft space for you to be able to benefit from in that way. And usually it's fitted so that there's the kind of supply vent for it is at the top on a stair landing, and it's kind of pushing down onto your stairs and your lobby. It is simple and quite cheap to install, and it does often kind of get rid of condensation problems. What I'm concerned about is that it can be doing that job if your house has got those kind of cracks and gaps and hasn't been made very airtight. It's pushing that warm, wet air into the building fabric. People have complained a little bit about comfort issues as well with cold air, because even that's come from the loft, it's not going to be super warm. So cold air being pushed into rooms. It can be quite costly to run as well. Some of them put a preheat element into the unit, and that's just direct electric. And I know some of my neighbours here have had issues with that. I wouldn't recommend it necessarily. There's an article I can probably add on to the slides before they get sent around that goes into more depth, but one to be aware of, but yeah. And then we've got system 3, which is just centralized mechanical extract. So this is where you have, similar to some of the other systems, you have trickle vents or wall vents in your living spaces, so your bedrooms, living rooms. And then you've got ducting to a central fan unit that is sometimes located in a loft, sometimes in a cupboard. And that has just one fan that's drawing the air out of the building that way. It can work on a manual switch, or it can be humidity controlled or on a presence sensor in different rooms. It's good in a way because it limits the number of holes you need to put in the building fabric. And it does reduce energy use by having a single fan, and can help with noise as well, because the box that the extract, the fan unit is in, can be sound insulated to a degree. Some of the systems are also able to modulate quite well, so they can kind of ramp up and down the amount, the speed at which, or the pressure that's generated, so the volume of air that's being removed, depending on the levels of humidity. It is a bit more complex and expensive to install than other forms that we've talked about before. And depending on where you position your inlet vents, there can sometimes be issues with comfort because you've got a cold air supply. Yeah. On a similar kind of approach, but rather than having the centralized unit, you've got extracts running just in wet rooms, so they might be through wall or short duct runs in your bathrooms and your kitchens. This is essentially the same thing, just with individual extract units rather than a centralized fan, centralized unit. This can be quite good because it's simple and relatively cheap to install and run. The centralized unit works quite well if you've got a house where your kitchen and your bathroom or your wet rooms are stacked, so that the ducting is relatively straightforward. This can be a better solution sometimes if the plan of your house doesn't allow you to do that, and that running those ducts to the central unit would become too complex. Something to watch out for with it is to make sure that the extracts are properly sized. There has been a bit of a tendency for smaller extracts to go in, that then to achieve the right level of extraction, to achieve the air quality that you need, have to run at a higher speed. That means that they're noisier, which then means they risk getting turned off because you get annoyed by them. There's some of the same issues with a potential cold air supply as well. So depending on where you position your intake units, there's guidance on where the best place is to position those. Usually you're trying to do it at a high level, so there's some kind of mixing, so either in the very top of a window although there are issues with putting them in windows, because if you draw curtains over them, they're not going to work quite as effectively. Or if it's a wall, then it's kind of up near the ceiling. But in a retrofit, especially, it's not always possible, or you maybe don't have the space to get things in the ideal position. So it's just something to watch out for. And then I think finally, Building Regs System 4. This is kind of the all singing, all dancing. It's doing heat recovery. It's doing both supply and extract. It's the most expensive system, but it's probably also the one that is the most controllable, gives you the opportunity for the highest levels of comfort. What I would say, from having done post-occupancy evaluation again on a lot of this, is if you're going to go for this, do it right, because if you and have the budget to be able to do it right, because putting in an MVHR, a mechanical ventilation with heat recovery unit, and doing it badly can result in worse outcomes than even some of the kind of much cheaper, more kind of bog standard systems. So if you're going to do it well. The difficulty in retrofit with this is always where to run the ductwork. So if you're doing a full strip out of your house back to the brick, and you're able to run ducts where you need to, then it can be great. If not, it can be a bit of a struggle to get the space and to not cause too much disruption. And working out where all those ducts are going to go. Yeah, that's the kind of type of unit that you might get. I suppose the other thing is finding space for the unit itself, and making sure it's somewhere that you can get to it, because the filters in it will need changed on occasion. And the number of times that you see mechanical ventilation heat recovery units fitted that you then can't actually get to change the filters, kind of defeats the object a little bit. So putting it somewhere accessible is a good idea. Oh, sorry, yeah, forgotten. Finally, there are decentralized mechanical ventilation heat recovery units. So these are basically fan units that do supply and extract just through a single hole in the wall. Advantage can be that they're quite simple to install. I would like to see more data on it, but I think there's a potential for overventilation, because you're basically having to, whereas most of the other systems rely on air coming into a living or a bedroom, being transferred across and taken out from a wet room, these are kind of trying to do the supply and the extract in a single room. So you almost have to double the ventilation rate. And I'm not sure how that might affect balance across a whole house, but in a particular circumstance, they can potentially be quite useful if you've got a single problem room that you want to deal with, or somewhere that isn't accessible as part of the overall ventilation system in a whole house. I'd be interested to know a bit more myself about how you might balance those across a whole house. Okay. So yeah, that's a run through of all the different types of ventilation system. There is some simplification in that, because you get hybrids and you get kind of different systems put together. But I'd say those are the key ones really that it's useful for you to be aware of. I will finish in a moment, but just to say before I do that there are, here we've been talking about systems that might cost hundreds, if not thousands of pounds to install as part of your retrofit plan. There are some very simple things you can do now that will improve air quality in your home and help you be more comfortable and safer as well. So if you have a fuel burning appliance and you don't have one yet, please get a carbon monoxide monitor. getting hold of a hygrometer can be really useful and informative. So you're kind of tracking the levels of humidity in your home. If you have trickle vents in your windows, please do use them. I know they can cause a bit of a draft sometimes, but taping over them or closing them up all the time, it really doesn't help your indoor air quality generally. If you have manual switches for kitchen and bathroom extracts, make sure they're on when you need them to be. So like if you've had a shower and you need to manually switch your ventilation unit on, use it. Have a clean of any fans that you have. Dust and dirt really makes things run less efficiently, can also add to noise problems and cause, in the longer term, cause maintenance problems. Think about where you dry your clothes. So if that can be better ventilated, if you've got a cupboard or an area or something that you can use, or I know drying outside can only happen a few days a year, but that's obviously a good one as well. Trying to use lower VOC paints and materials when you are refurbishing, which is really common now. I mean, even Dulux and stuff do low VOC paints. And a very basic one is just to put lids on pans when you're cooking. It'll help you cook your food quicker, but it will also mean that you've got less water vapor going into the air. That's it. I think that's everything. I'm sorry I'm 10 minutes past where I said I would be, so we've only got about 20 minutes or so for the last bit, but there was a few extra bits in there that I'd slightly forgotten about, but never mind.
Thank you very much, Marianne. That's great. That's really interesting stuff for you there. Right, I think it's about time we're going to have to wrap it up now. So thank you very much for all of your questions. A couple of people in the chat saying thanks to Marianne specifically.
No problem.
I'll just quickly share my screen so at the very end of the presentation. So do let me know if you can see that. Are we all good?
Yeah, we can see that.
Perfect. So if your question's not been answered, then it might be covered in forthcoming webinars where you can ask questions there. We've got a few more retrofit things in the pipeline. We've got a couple specifically about, I think there's one about Windows, maybe one about, I can't remember off the top of my head, which is very embarrassing because I wrote them all. If you just go to www.cafs.org.uk/events, there's a whole load of other webinars that are all free, all of them this sort of thing, dealing with those things. So hopefully maybe you could get your question asked in another Q&A there. You can also request an advice call with a CAfS Energy Advisor or ask for a free retrofit consultation by phone. Or you can ask us to quote for our full energy advice audit. All the details are on screen now, provided that everything is working properly. And again, all these slides will be provided in the recording that you'll receive a couple of days after this webinar. Oh, there we go. If I'd held my tongue for a mere minute, I would have been able to provide that resource for you. So the Eco-Retrofit for householders, units 1 to 4, these are the ones that, this is the final one off, I believe. All the recordings for those are, apart from this one, obviously, are already on the YouTube channel, units 1 to 3. So you can check those out if you haven't already been on them. And if you have already been on them, then if you've been on all 4, then we'll get you a sticker or something like that. Windows webinars on the 24th and the 28th of March at 6 p.m. Again, you can book on, there we go, www.cafs.org.uk/events. And then we've got a repeat of our retrofit journey for householders webinar on the 20th of April and an introduction to construction contracts on the 19th of May.
Sorry, Kieran, I think everyone's just seen the very first of the slides, the end of Q&A.
Oh, really?
Slide. So yeah, I think sometimes it does this when you go to present from PowerPoint. It doesn't show the present bit; it shows you the.
Okay, what I'm going to do is I'm going to end slideshow and just.
Yeah, if you just flick through there, that'll do.
How does this work? Can you see that now?
Yeah.
Can everyone see that now? I'm just going to show it from the PowerPoint. Yeah. So I'll just leave that up for a couple of seconds so that people who were simply listening to me rambling and not looking at the clear information presented on screen will be able to see it there. But yeah, those are the webinars there, the dates and stuff. And you can also sign to our newsletter on our homepage at www.cafs.org.uk, which will also let you to any more events that are coming up. And we've got a new Facebook group all about Cumbria Green Build. If you wanted to learn from other people who are going through very similar sort of processes and trying to learn things about green building. As mentioned before, you can sign up to our newsletter at www.cafs.org.uk, join another webinar, complete our survey, which will be in the email that we sent to everyone. We'll send a link with the recording, with the slides, and with a link to our survey, which is all about different buildings and stuff like that, different building work that people are getting involved with, and contact our advice service. And thank you very much, as Tina mentioned at the start of the webinar, for anyone who donated when they signed up for the webinar for free. And I think that, oh, go on. And there we go. Not as much information to get across on that one, but thank you everyone thank you Marianne as well for a really interesting presentation. And
no, thanks for inviting me.
And thanks everyone. Hope you had a good evening with us all, and we'll see you next time. Take care.
Right, thanks everyone.